Hello again. Okay, so recently saw a movie which featured telekinesis as a major plot point. Got to thinking, what would it take to make telekinesis really work? Or is it telekinesis or telekinesis? I've heard it pronounced both ways. Um, no, I don't believe in telekinesis. Um, start off right there. But just out of curiosity, what would it take for it to work? So technically, or the actual definition is movement at a distance. So it is not moving things with your mind, it is moving at a distance. But at the same time, we're talking about where we want to control this. So people would think that it has to be moving with your mind. I can understand why people say that. So if you want to get really, really technical about it, strict definition of the word, gravity is telekinesis. Two objects with mass, they attract each other even from a distance. That's not what we're talking about. But it is a starting point, let's say. So motion, Newton's laws, an object at rest remains at rest until acted on by a force. An object in motion remains in motion until acted on by a force. So, telekinesis, we're going to move an object, whether I'm doing it with my mind or something else. I am applying a force to it, and it whoop, whoop goes up and down, assuming my hand wasn't there. So let's look at the known forces of the universe. We've already talked about gravity. There is gravity, there are electromagnetic forces, there is the strong force, and there is the weak force. Those are the four accepted forces. People have played around with the idea, is there a fifth force that we don't know about, or that would explain things we can't explain? The whole idea that dark matter is one of those things where we think in order to not collapse in on it, or in order to not blow up and just go off at random, there has to be matter that we don't know about, with gravity holding stuff together. And so we came up with the idea of dark matter, just matter we just can't detect. And some people have come up with the idea that maybe there is an actual fifth force which is keeping the universe together and not just gravity. So it's an idea to try to explain things without having this extra mass, without dark matter. Read an article once which was somewhat beyond my understanding, so I'm not going to go into too much detail, but they suggested actually that what they were thinking of as the fifth force was in fact dark matter. They thought they had come up with proof of dark matter, and then I've read other articles where no, we've come up with the idea that there is a fifth force, which is actually an interaction of other known forces. So not going to go there yet. But so we got the four forces that are known to exist, or have been proven to exist. Now gravity, that's the earliest one we've known about. It is basically two objects with mass will attract each other. We don't know exactly why. But we do know that they follow the same rules apparently over and over again, and so we believe gravity exists from this. You can calculate the gravitational force. It is the mass of the two objects multiplied by each other, divided by the square of the distance between the two of them. So the farther away they get, the less force they apply to each other. The larger the mass is, the more force they apply to each other. And those are multiplied by g, the gravitational constant of the universe, 6.67 times 10 to the minus 11 Newton meters squared per kilogram squared. Okay. Electromagnetic force is similar, only instead of mass, it's the charges. Two charged particles will either attract each other or repel each other. Like like charges repel, opposite charges attract. I think everyone knows that from like cartoons. And so it's Q1 times Q2 instead of M1 times M2, the charges of the two objects. Still divided by the distance between them squared. Instead of C we have, or instead of G we have C, which is Coulomb's constant, which I don't remember off the top of my head. But it's basically the same equation as gravity with charge instead of mass and C instead of G. Now we're going to skip to the weak force. Weak force was actually the fourth one which we discovered / proved existed. So it's a lot more complicated. What is it for? I'm not 100% sure. I know it was when we were studying neutrino, or not neutrino decay, neutron decay, or beta decay, that we started coming across the weak force. And so it deals with holding neutrons together. It's also used with neutrino, pathways of neutrinos and stuff like that, which neutrinos come from beta decay, so that makes sense. Okay, so we got to break down the atom into bosons. Those are just a word for certain subatomic particles. I think some, actually, no, not going to go down that way. But so we got the 2W bosons and the Z boson. W bosons are charged, either positive or negative, and the Z boson is neutrally charged. So to some extent we are pulling a little from electromagnetics into it. Now, trying to explain all this, I don't fully understand it myself. Like I said, I've studied beta decay, I've studied other aspects where the weak force is used. I've never deeply studied the weak force itself, so I'm not going to try to explain it now. Did a quick check online to try to, how can I explain this in simple terms, and I can't. The online doesn't give a quick, simple, easy answer. Now, I did find out the weak force. Several sites say it does not have a simple formula like the gravitational or electromagnetic force. Although, like I said, there are the positive and negative W bosons, so charge might come into it a little bit. And also, most sites did say that the mass of the boson comes into it, so it's sort of like gravity, and that it does drop off exponentially with distance between the bosons in effect. Which, again, sounds very similar to the last two formulas we looked at. So mass is involved, charge is potentially involved, and it does drop off with distance between them. But it's definitely different from the other two. So, again, this is all information gotten from websites trying to explain it. I'm going to assume there are more factors within the formula which they just don't go into. I didn't actually find the formula written down anywhere. So, one thing that they were very emphatic about was it drops off exponentially to where it doesn't exceed the radius of the atomic nucleus. So one atom's weak force will not affect another atom's weak force, except that it drops off exponentially. And dropping off exponentially, you never reach zero. So the weak force of each atom in the universe still affects each other. It's just very weak. Now, again, what we have looking at with the whole beta decay and neutrino creation, we can't argue that you need a certain force strength for these to work. and therefore getting outside of the radius of a nucleus of an atom, it's going to be too weak to really affect. It's actually touching another atom, but it's too weak to cause beta decay or neutrino creation or anything within the new atom. So, to that extent, we can say yes, its effect is negligible, but it is still applying a force that goes on infinite distance. It just drops off so rapidly that it becomes negligible. Then we have the strong force. Strong force was actually proposed before the weak force. It might have been actually discovered before it. Did not look up dates on those. And the idea there was we've got positive charges attract, negative charge, or matching charges repel, opposite charges attract. We got that from electromagnetics. And an atom, the nucleus of an atom is made up of positive charges. So why doesn't it just fly apart? Because you got all these positive charges next to each other. And so someone suggested there has to be a stronger force holding the atom together. We call it the strong force because of that. And it deals with, again, subatomic particles interacting with each other. And I did find a few equations on it, which kaboom! My mind explodes just looking at them, trying to explain them. No. So the weak force, again, they say it's completely different from the gravitational and electromagnetic forces, but they don't give an equation for it, but their description makes it sound like it's similar. The strong force, completely different. Now again, the strong force, it was named that because it is stronger than the electromagnetic force, and therefore it allows nucleuses of atoms to stay together, but it is also weak enough that it's not affecting other atoms around it, so it's not just drawing in other atoms. So it's still somewhat weak in a sense. Anyway, so let's look at these and say, how would telekinetic forces work then? So let's assume. So we got three ideas on this. The first being telekinetic force is just one of the other forces. It is manipulating gravity, for instance. That would be the most logical one. Some would say manipulating electromagnetic charges. My second theory would be it's a combination of them. So we're affecting matter in total, so we're getting down to the nucleus of it, we're getting down to the electrons around it, so different forces are in play. And the third one would be it's a completely different force altogether. Now, thing about it, we think of it as being controlled with the mind because it's, again, being done from a distance. And that's the best way we can describe it as being controlled. And that's what allows us to do things like move things sideways. The other forces, as we know them, they are, you've got two objects or two charges or two subatomic particles, and the force works between the two of them. It doesn't, repel, attract. There is no lateral movement away. This one's going this way, and it's radial to each other. Telekinetic forces, I can lift something up, then move it to the side and move it down. So that's where we would be thinking, if there is an effect on it, it's probably manipulating other forces. It wouldn't be actually putting a force on it. It would be more similar to remote control, only it's remote control with the mind. So telekinesis would not actually be a force of and by itself. It would be manipulating other forces, most likely. Now the question comes, how do we do this? In the movies, there's always like the person first learns about it through a emotional event, and something makes him angry and he pushes something away with his mind. I mean, that would sort of make sense, especially he has no control, so it's more radial. than it is moving things side to side. He has to practice with it in order to get it to work, to start doing other motions with it. That would make sense. So how do you control it? I mean, people have done that. They've sat there and they've stared at stuff over and over and over, just hoping to push it away or move it towards them. Or that's another thing with the whole emotional thing is it always starts with the person pushing it away in the movies. You know, as long as the radio, why not pulling it towards you? You know, I really, really want something. My desire is for it to come towards me. That could be an emotional response. But typically, it would be a weaker emotional response than pushing something away. You know, fear, anger, those you push stuff away with. Although I guess anger, you could pull something towards you if you really want to hurt it. So, in the movies at least, you know, telekinesis would start with a radial motion, and then as you learn to manipulate it, you can start doing things sideways and up and down. But again, that's getting more into this is a remote control thing rather than a force oven by itself. So you are manipulating forces, known forces, as opposed to creating a new one. And then we get into, so how do we actually do this? In order to do that, we'd have to believe the whole quantum mind thing, where we are more deeply connected with the universe than we think or than we know, because we are affecting every force that affects this object. We are overpowering it in some way that we don't know. You know, we think in terms of, oh, I want this to rise, I want this to lower. But what's actually happening at the atomic level, subatomic level, whatever, is there are other forces that we are manipulating, pushing it, nudging it. You know, and we aren't calculating all that. Or at least, that's not how it's portrayed fictionally, at least. In reality, you know, if we were to actually believe in telekinesis, which again I don't, it would be not thinking if I want to move the object, it would be thinking what natural forces would I have to change in order for the object to move. And again, we'd be getting down to a level, you know, we'd have to take the mass of the object into play, we'd have to take any electrical charge on the object into play. And you know, with this weak and strong forces, we would have to actually start considering what's going on at an atomic level with the object. So, is it possible? Again, I don't think so. I don't think humans have the ability to process it like that. The idea that we would subconsciously, you know, the mind at a quantum level would somehow jump to where it's doing all these equations and moving stuff around. Maybe, but I don't think it's something we can actually teach ourselves. The idea that people actually do have this ability, I don't believe. You know, I've never seen any reason to believe it. And everything, you know, the experiments we've done with it is, again, the people trying to move the object without thinking about how they're moving it, or why it's moving, or anything that I would expect to take place. So that is it. Either, my theory is, for telekinesis to work, we would have to think on a deeper level than we are, or would just have to be a completely different force which uses none of the rules of any other force that we know of. That is it. Have a nice day.